Okay, so unit step function. So let me define what is unit step function. So today we have defined it. U of t minus a equal to the value of this function is 0 when t less than a and 1 when t greater than a. So if we plot the graph of this function, this is t and this is u of t minus a y-axis. So if a value of function is 0, it is 0 when t less than a, and if it is 1 when t greater than a. So this is the function graph of the function. And first we will find the Laplace transform of this unit step function u of t minus a. This is equal to, by definition, this integral 0 to infinity e raised to minus st u of t minus a dt. Now tell me what is this integral. So this we can split into two, right? One is 0 to a e raised to minus st, and from 0 to a, that means t less than a, what is the value? 0, right? dt plus a to infinity e raised to minus st, from t greater than a, the value of function is 1. So 1 dt. If we integrate this, you will get minus a to infinity. So what is the value of e raised to minus infinity? E raised to minus infinity, that means e raised to minus infinity
Theorem.
0. E raised to minus sa, right? Or as. So this is 0 and this is equal to e raised to minus as by s. So Laplace transform of unit step function is L of u of t minus a is equal to e raised to minus as by s. So this is the Laplace transform. Why this Laplace transform? Why we define unit step function is we can find the Laplace transform of function defined on the interval. So, so if function is defined in some interval, still we can find the Laplace transform of that function. For example, we will do two problems. Why we are using Laplace transform of unit step function? We can find Laplace transform of functions defined on some interval. So if a function defined on some interval, then still we can find the Laplace transform. So first question, find find Laplace transform of. Okay, before going to that, I will define what is second shifting theorem. Okay. So then we will do second shifting theorem. Shifting theorem. The second shifting theorem states that we already studied first shifting theorem. Second shifting theorem states that if L of f of t is equal to f of s, it means Laplace transform of f of t is equal to f of s, then Laplace transform of f of t minus a. So here our parameter is t minus a into u of t minus a. So variable is t minus a is equal to e raised to minus as into f of s. So what is f of s? F of s is Laplace transform of f dash of s. Or we can still write Laplace transform of f of t into u of t minus a. That means we are changing it into f of t. That means Laplace transform of f of t into u of t minus a. This can be written as Laplace e raised to minus a is L of f of t plus a. So what is a? So this formula we will use to find the Laplace transform. Similarly, we can find the inverse Laplace transform. So what is inverse Laplace transform? So inverse of this. Okay. So now we will do a few problems. First one, find Laplace transform of f of t is equal to cos 2t defined on the interval 0 less than t less than pi. So here our function is defined on the interval, okay, 0 to pi. So now in order to find Laplace transform of such function, we will write it in uh, unit step function. So how to write? Then we have given f of t is cos 2t when t is in between 0 and pi, and 0 everywhere else. We will take 0 everywhere. So in the interval 0 to pi, the value is cos t, and in the interval for all other values this value is 0. So how to write this? We can write it as cos 2t into u of t minus 0. That means what in the u of t minus 0 means cos 2t is u of t minus 0 means it's 0 when t less than 0 and cos 2t when t greater than 0. And also we know that it is defined only at 0 to pi. So I want when t greater than pi, I want cos t must be equal to 0. So what you can do is this minus cos 2t into u of
t minus
minus pi. Right?
pi.
So we will get this value. Okay. So on the interval, the value of f of t is this. Now you can find the Laplace transform. Laplace transform of f of t is equal to, I can write a Laplace transform of cos 2t into u of t minus 0 minus Laplace transform of cos 2t into u of t minus pi. So നമുക്ക് ഇത് യൂസ് ചെയ്താൽ മതി. If we are using this, then we can easily L of f of t into u of t minus a is equal to e raised to minus a is L of f of t plus a. So here, okay, in first case, what is a here on the first Laplace? Here a is 0, right? A is 0.
Yes, sir.
So what is Laplace transform of this? You can write e raised to minus a 0 s into Laplace transform of we will replace t by t plus 0. So that is Laplace transform of cos 2t plus 0. So that is cos 2t minus, tell me what is this? ഇതെന്താ വരിക? ഇവിടെ a എന്താണ്?
pi.
Pi. Then what e raised to minus pi s. What is this? Laplace transform of cos of 2t plus pi. Cos of 2t plus. Now we will write. So this is e raised to minus 0 is 1. L of cos 2t is what is this? 2 by um, 2 by s square plus, sorry, so this is 1 into L of cos 2t. L of cos 2t is s by s square plus 2 square minus e raised to minus pi s L of cos 2 into t plus pi. So how to do this? Anybody have any idea? Okay, so this is actually we will find that by using. Okay, let us do from here. L of cos 2t plus pi. This is actually equal to L of cos 2t plus 2 pi. This is equal to L of, what is cos a plus b? Cos a plus b എന്താണ്? Cos a, that is cos 2t into cos 2 pi minus
Sin 2t
2t minus into sin 2 pi. Sin 2 pi is 0, right? So this will become 0. So the remaining is cos minus cos 2 pi. You can take outside L of cos 2t. So this is equal to,
2 ആൻസർ മൈനസ് 1 ആണ്.
എന്താണ്?
അവിടെ നെഗറ്റീവിലല്ലോ, കോസ് 2 പൈ മൈനസ് 1.
Okay, cos 2 pi is 1, right?
Yes, sir.
Okay, s by s square plus 2 square x. So this answer is s by s square plus 2 square minus e raised to minus pi s into s by s square plus 2 square. So this is the Laplace transform of this function cos 2t on this interval. So നമുക്ക് ഇതേപോലെ we will do a problem to find the inverse Laplace transform of unit step function. And find inverse Laplace transform of inverse Laplace transform of, I will do this 4 into 1 minus e raised to minus pi s divided by s square plus 4. You should here there is e raised to minus pi s. That means e raised to minus as. Oh, right? So so here it involves unit step function. So we will find the answer. So we have to find the inverse transform. L inverse of 4 into 1 minus e raised to minus pi s divided by s square plus. Okay, tell me what is uh, so here 4 is common. I'm taking outside. Then L inverse of what is this? 1 by s
S square plus
square
4
plus
square
4 2 square, right?
2
2
square
square
minus
minus e raised to minus pi s. Sorry,
yes,
L inverse of, right? L inverse of e raised to minus pi s divided by s square plus 2 square.
ആദ്യം ആ ബ്രാക്കറ്റിൽ കിടക്കണ കണ്ടുപിടിച്ചിട്ട് പിന്നെ എന്ത്
ചെയ്താലും
ചെയ്യാം?
മതി. 4 into what is Laplace transform inverse transform of 1 by s square plus 2 square? Inverse of 1 by s
സൈൻ
square 2 square. That is sin
സൈൻ 2t/2
2t by 2. Good. Minus. Now it
e raised to
involves unit step function, right?
yes sir
ഇവിടെ a എന്താണ്? e raised to minus pi s. So a is pi, right?
yes sir
Okay. Now what is e raised to minus pi s divided by s square plus 2 square? What is Laplace inverse? We know that L of f of t minus a
pi
into u of t minus a is e raised to minus a is f of s, right? Then so what is the answer? This is e raised to minus, okay, e raised to L inverse of e raised to
t
minus
minus
pi s into 1 by s square plus 2 square.
yes sir
So f of s is here 1 by s square plus 2, right? This is
ah
okay. Then how you can write it as a step function for sin 2t
t
by
minus
minus, okay, t ആണോ?
t minus അല്ലേ ഇൻവേഴ്സ് ചെയ്യുമ്പോൾ ടിയിലേക്ക് ചെയ്തിട്ടുണ്ട് t minus pi സൈൻ
Sin t അല്ലേ? Sin, this is actually sin 2t minus pi
pi
അല്ലേ? Okay. Sin 2t minus pi divided by 2,
2
right?
yes
That is f of t minus a.
okay
And because here f of t എന്ന് പറയുന്നത് sin 2t, right? By 2. So we have inverse is, if you take inverse Laplace transform, it is f of t minus a into u of t minus a is equal to L inverse of e raised to minus a s f of s.
കാരണം അവിടെ ഇപ്പൊ എസ് ബൈ എസ് സ്ക്വയർ മൈനസ്
S
2
by
സ്ക്വയർ വന്നായിരുന്നെങ്കിൽ
s by
എസ് സ്ക്വയർ മൈനസ് 2 സ്ക്വയർ ആണ് ഇൻറ്റു ഇ റേസ് ടു എസ് എൽ ഇൻവേഴ്സ്
and
ആണെങ്കിൽ അത്
this
കോസ്
sin cos 2t
ടി മൈനസ് എ
അത് വരും. Okay, have you got it?
യെസ്
Into there is step function is there. What is that? U of t minus pi, right? U of t minus pi. Okay, so this is the answer. So similarly you do
ടി
other.
മൈനസ് പൈ നമുക്ക് അല്ലാതെ കണ്ടീഷനായിട്ട് എഴുതാൻ പറ്റുമോ
ആ
ടി
എഴുതാം.
ഗ്രേറ്റർ ദാൻ
ആ അങ്ങനെ എഴുതാം. So,
എങ്ങനെ സാർ കാണിക്കാം?
so അപ്പം this is equal to
ടി ഗ്രേറ്റർ ദാൻ പൈ തിയറി.
t t this is equal to 4 sin 2t by 2 when t less than pi. This quantity will be equal to 0, right?
യെസ് സർ.
And when t greater than pi, you can write 4 times sin 2t by 2 minus sin then also sin 2t by 2t by again sin 2t by 2 അല്ലേ sin 2t by 2 ആണ്. Okay, correct. This will become 0. Okay. So actually this is L of this function is 4 sin 2t by 2 when t less than pi. So this is the function. F of t is equal to 4 sin 2t by 2 when t less than pi. Okay, have you got it? So it's a Laplace 0 less than t less than pi. Sorry, 0 less than t less than pi. We have 4 sin 2t by 2. ഇതാണ് ഇത് വരിക. ഇതിൻ്റെ ലാപ്ലേസ് ട്രാൻസ്ഫോം ആണ്. Okay, so you can write just we can check that f of t equal to 4 into sin 2t by 2 when 0 less than t less than pi. You can write it as 4 into sin 2t by u of t minus 0 minus 4 into sin 2t by 2 u of t minus pi, right? So if you take Laplace transform, you will get the above function. Its Laplace transform is same as this. Have you got it? Any doubt? Any doubt?
നോ സർ.
Now we will move to
ഗാമ ഫംഗ്ഷൻ റൂട്ട് ടി.
okay. അത് ഞാൻ മറന്നുപോയി. ഞാൻ ഇന്ന് ചെയ്തിട്ട് അയച്ചത് റൂട്ട്
ഓക്കെ
ടി.
സർ, താങ്ക് യു സർ.
So now we will define what is Dirac delta function. Dirac delta function. Delta. Okay, so let me define what is Dirac delta function. Dirac delta function is defined as denoted by delta t minus a. This is equal to 0 when t not equal to a and infinity. So this is notating by infinity when t equal to a. So this is Dirac delta function and also satisfies one condition, integral minus infinity to infinity delta t minus a dt must be equal to 1. So if any function that satisfies this condition, then that function is called a Dirac delta function. So this so intuitively this is like something everywhere it is 0 and except uh, at a it is infinity. So 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 it is very difficult to find such function, but such function is existing. So I will model a function, Dirac delta function. That is, if I am taking a function fk of t minus a. If I am defining, it's 1 by k when a less than t less than a plus k, and equal to 0 when otherwise. Okay. Now, what will happen here if I am taking limit k tends to 0, fk of t minus a? What is the value? ഇവിടുന്ന് k 0 ലേക്ക് പോകുമ്പോൾ what is the value?
Infinity.
It will be like infinity, right? 1 by
Yes, sir.
0. And if k is 0, that is a less than or equal to uh, t less than or equal to a. That is when t equal to a and 0 otherwise. So this function is something like, if I am taking k tends to 0, then it satisfies delta function. Okay. Similarly, if I integrating integral minus infinity to infinity fk of t minus a dt is equal to integral a to a plus k 1 by k dt. So this is actually equal to 1. So this is a model function of Dirac delta function. So that is when k tends to 0, this function is actually a Dirac delta function. So now we will find the Laplace transform of Dirac delta function. There are many applications in physics and engineering with the Dirac delta function. So there are many physical significances. So now we will find what is Laplace transform of delta t minus a. So I am just giving what is Laplace transform of delta t minus a. This is actually equal to e raised to minus as. E raised to minus as. So you note it down. And L of delta t minus a is equal to e raised to minus as. Actually, you can find it from here. Laplace transform of f of kt minus a is actually is equal to integral 0 to infinity e raised to minus st fk of t minus a dt. So this is actually is equal to a to uh, a plus k e raised to minus st into 1 by k dt. So if I am taking this, it will be 1 by k outside e raised to minus st divided by minus s when a plus k. So this is actually equal to 1 by k times, or I am taking e raised to minus s into a plus k minus e raised to minus as divided by minus ks. I can take e raised to minus as outside. There is minus n and minus plus. So I can write 1 minus e raised to minus ks divided by ks. Okay. So നമുക്ക് Dirac delta function എപ്പോഴാവുക delta t minus a when k tends to 0. If I am applying k tends to 0 here, you can take e raised to minus as limit k tends to 0, 1 minus e raised to minus ks by ks. So this limit is equal to 1. Okay. So you can use L'Hopital rule and we can find that. So this is Laplace transform of e raised to minus. So, so please note it down. Laplace transform of a Dirac delta function is e raised to minus as. So this is something like intuitive approach. An intuitive approach for finding Laplace transform of Dirac delta function. And also I will give you a form. What will be Laplace transform of f of t into delta t minus a. F of t into delta t minus a. So actually, if f of t into delta t minus a is something like at a, the value will be f of a going like f of a into delta t minus a. This is going to infinity, right? So I'm only giving the formula Laplace transform of f of t into delta t minus a is equal to e raised to minus a f of a. Okay, so please note it down. This is Dirac delta function. L of f of t delta t minus a is equal to e raised to minus a s f of. Okay, so I'm not giving the proof. Proof is somewhat intuitive approach to find the integral of this function. So you just note it down, and I will give you a question. So if you want to find a Laplace transform of t square delta t minus 2. Laplace transform of t square delta t minus 2. Tell me what is this Laplace transform? Very easy, right? Laplace transform of t square delta t minus 2. What is Laplace transform?
e raised to
E
minus
raised
t minus 2s
minus 2s into
f of t.
f of
Yeah.
2, right? F of 2. So that is equal to e raised to minus 2s into f of 2 is 4, right? 2 square. Here f of t is t square. Similarly, you can find the Laplace transform of, if we want to find Laplace transform of find Laplace transform of cos ht delta t minus 4. ഇതെന്തായിരിക്കും? So here f of t is cos ht.
T.
So this is e raised to minus
Cos h. Cos h t.
4s cos h
T minus 4.
t
അല്ല
minus 4, വെറും 4 f of 4
1.
അല്ലേ?
Yes, sir.
So this is very simple, but the um, deriving and Laplace transform, there is some intuitive techniques. You just want this, you just find study that form. So now we will do a problem solving ODE by using Dirac, which involves Dirac delta function. So we will do a problem. So our question is question one. Solve IVP. Solve IVP. Y double dash plus 9y is equal to delta t minus pi by 2. solution. Okay, taking Laplace transform, what you will get? Laplace transform of y double dash 9 into Laplace transform of y is equal to Laplace transform of delta t minus pi by 2. Right? What is Laplace transform of y double dash? Do you remember that?
S square
S square
L of y
L of y minus
minus
S
y of 0
y of 0 minus.
minus y dash 0.
So I will give you what is y of 0 is 2 and y dash of 0 is equal to plus 9 times L of y is equal to what is Dirac delta function Laplace transform of
E
delta
raised to
to
minus 2 S1
e raised to minus
pi by
pi
2
by
S
2 s, right? Pi by 2.
S
So this is equal to, I'm
L
taking
of y
s
outside L of y
square, okay, s square and
minus
9 plus 9 like
S plus
square plus 9 L of y minus y of 0
2s
is 2 2s y of
L
0 is 0 which is equal to e raised to minus pi
pi
by.
by 2 S L
Now
of y
L of y is equal to e raised
E
to
raised to
minus
minus pi by 2
2
S
is
plus
plus
2s
2s
by S square plus 3 square
y x square plus 3 square x square
y
plus.
equal
So y equal to
L inverse of
L inverse.
split here.
L inverse of um, e raised to minus pi by
Sir,
2.
അവിടെ E raised to വന്നുകൊണ്ട് നമുക്ക് സെക്കൻഡ് ഷിഫ്റ്റിംഗ് ഉപയോഗിക്കാൻ പറ്റും.
That is second shifting will be 3 square plus 2
2
into
into
L
S
inverse of s by s square plus 3. So what is this? This is actually L inverse of e raised to minus pi s into 1 by, sorry, okay,
S by
1 by s square plus
3 square
3 square plus 2 into what is this Laplace transform of
sin
s
3 t by 3
cos 2t cos 3t, right? S by s square plus this 2 into s L inverse of s by cos.
sir.
Okay, now what is Laplace transform of this? Here a
Sin
in place of a, this is pi by 2, right?
yes, sir.
Now
Sin 3
f of s is capital F of s is actually 1 by s square plus 3 square.
sin 3 t by 3
Okay, then
yes,
3t by
3
so
t
this
is stand t minus pi by 2
pi by 2. So the answer is
sin
actually sin 3
3 into t minus pi by 2
3 minus pi by 2
by 3
by 3 into
u
u
into t
of
minus pi by
3 plus 2 cos 3 plus 2 cos. So this is the answer. So that is y. So similarly, you can do other problems. I will give you a homework for solve solve the IVP y double dash plus 4y dash, sorry, plus 4y is equal to delta t minus pi minus delta t minus 2 pi, where y of 0 is equal to 0 and y dash of 0 is equal to 1. So please do this problem.
മുകളിലത്തെ ഫംഗ്ഷൻ നമ്മൾ